Okay, good morning. Welcome to
FamilyMath209a.
Family Math number 209a. So today we're going to be talking about the short video that we saw yesterday. It was a lecture by Jacob Lurie, who's a mathematician at Harvard. He is an American mathematician, and he participated in the International Mathematics Olympiad when he was a kid, and then he got a PhD in math, and he just won a prize called the Breakthrough Prize, which I think had a $2 million or $3 million prize.
I think it was a $3 million.
$3 million? Yeah, it's a pretty big prize, and 5 different mathematicians won it. Let's see if I can remember their names. Terry Tao, who you've heard of.
Yeah.
Jacob Lurie.
Who we're going to talk about.
Maxim Kontsevich, Simon Donaldson, and Richard Taylor. So hopefully we'll talk about all their videos, but Jacob Lurie is just, happened to be the one I watched first. And they were supposed to be giving lectures to the general public, like that Terry Tao lecture we saw at MoMath.
Yeah.
And he talked about the numbers. Okay? And he started with counting numbers. I don't remember if he included 0 or not, but we'll include it. 0, 1, 2, 3, 4, etc.
Yeah.
And what did he say was an interesting set of numbers to think about after you thought about these numbers?
Well, integers, which include negative numbers.
Which include negative numbers. So, ... -3, -2, -1, 0, 1, 2, 3. Okay. And what would be an interesting or important thing to think about after you think about the
It
integers?
was like the rational numbers, like the fractions.
Fractions, like for example,
1/2.
1/2,
3/4.
3/4.
And you still have these numbers in there.
That's true.
So you can say 2.
2. It's a very important point, actually. That as you generalize the numbers you're thinking about, the previous ones are always included. Just like the non-negative integers were included in all the integers.
And
then all the integers are included in the fractions. Remember what was after this?
I think it was the irrational numbers.
Oh, the
like
real numbers.
The real
like
numbers.
the square root of 2.
This includes things like the square root of 2,
Pi,
pi,
e.
e.
And you still have some stuff like 3/4.
Yeah, can you think of any, do you know any other irrational numbers?
Well,
Square root of 3.
Ooh, good, square root of 3. You know, a funny thing, no one knows if pi plus e is rational or irrational. I don't think, anyway.
It would be like around maybe 5 or 6 since e is about 2 and pi is about 3.
Yeah. And then what came after this?
Well,
the
then
complex numbers?
Like what?
the 2 plus I.
2 plus I.
It was like, maybe there was like 3 plus square root of 2.
Well, that would fall there.
That would be part of the complex numbers, you're right. But it would really, we could talk about that one here with the irrationals, 3 plus the square root of 2.
Like, you could do 3 minus 2i.
3 minus 2i. 2 pi I, how about?
2 pi I.
2 pi I. And the reason he said, or one motivation he gave for studying these kinds of numbers is you can solve more and more different kinds of equations as you go along the way. Here you can solve x plus 3 equals 5. Right?
Yeah.
You know what I'm saying?
Yeah. Down there.
What is it? What is it?
Well, you can find x equals 2.
That's right. But inside of these numbers only, you cannot solve x plus 3 equals 1.
You need
Because
these numbers.
You need
You have some number of apples, and I give you 3 apples, and now you have
1 apple.
doesn't seem to make sense inside of these numbers.
But if you go to these numbers, the negatives, it'll make sense.
Well, we can solve it. I don't know if it'll make sense or not.
Well,
but
you can make
solve it.
minus 2 plus 3 is 1.
Okay.
But you can't really have minus 2 apples.
Yeah, so it's interesting. The negative numbers were very confusing to people. There was an Italian mathematician, I think in the 1600s, who called he called negative numbers absurd numbers. And before that, people didn't even really think they existed. They were very confused by negative numbers originally, for exactly the reason I said. What does it mean to have minus 2 apples?
No.
But you can't solve equations like this. 2x equals 5 with the integers.
No.
You need the fractions.
You need the fractions. So now you have the fractions, but you still can't solve things like x squared equals 2.
Then you need
No.
these numbers.
Yeah.
And then,
And these are all pretty simple equations, right?
yeah.
Yeah.
And so this is how mathematicians got interested and found these other numbers. And then finally down here you can't solve things like x squared plus 1 equals 0 without including the imaginary numbers. And you can see back, when I said negative numbers used to be called absurd numbers or ridiculous numbers, something like that. Even now we call this imaginary.
Because you can't have square roots of negative numbers. It's imaginary.
Well,
That's what they call it,
but
but
you can write it down on
you
the
can
board.
write it down and you can think about it, right?
Yeah.
So if you can think about it, is it real?
It's sort of real.
Sort of. Okay, well good. Let's move on and we'll talk about what he talked about next, which is who sort of realized what was the same about all these things and gave you a way to study these different kinds of number systems. Okay?
Yeah, alright.